Hello HMS modelers, I'm Greg Karlovitz, Senior Hydraulic Engineer at the U.S. Army Corps of Engineers Hydrologic Engineering Center, and this is your introduction to Meteorologic Models and HEC-HMS. Before we start discussing the Meteorologic Model, let's go over a brief review of the HEC-HMS user interface. The top bar of the window contains several menus. The most important menu for working with the Meteorologic Model is the Components menu. Beneath the menu bar is a collection of toolbars. Aside from the well-known buttons on the left, these buttons and menus are mainly for working with the basin map and for viewing results. The Watershed Explorer in the top left contains an organized tree of all the components in the project. Components include things like basin models, meteorologic models, and so on. As you add complexity to your project, the tree grows and keeps everything organized for you. The component editor in the bottom left lets you edit the component that you have selected in the Watershed Explorer. This is the most common way to change settings or parameters for components. The basin map in the top right gives you a view of the basin model that you're currently working with. And finally, the message console in the bottom right alerts you to what HEC-HMS is doing. It will display warnings and errors if they occur. Water can only enter the system in two ways in HMS: through a hydrologic element that produces discharge, for example source elements, or through the atmosphere. A meteorologic model can be used with any number of basin models as long as they are set up to do so. The name of the meteorologic model is deliberate. The MET model is more than just a set of data. It contains several models for representing atmospheric processes. However, it is not an atmospheric model in the vein of a weather forecast model or a GCM. For example, there are precipitation methods that take precipitation gauges as inputs and compute area averages from them in a couple different ways. There are methods for computing potential evapotranspiration from atmospheric data. The MET model controls simulation of snow accumulation and melt, and so on. The simulation run is one type of simulation available in HEC-HMS, and it's the most used one. All simulation types require a basin model and a meteorologic model. The control specification is unique to the simulation run. Creating a MET model is just like any other component. You can use the Components menu with the Create Component option, or you can go down to the Meteorologic Model Manager and create a new one from there. Going through the manager lets you see the other MET models in the project if there are any, and it also gives you the operations that you can use for creating a new MET model from scratch or copying an existing one. You can also rename or delete existing MET models from the Meteorologic Model Manager. To access the component editor for the MET model, click on the MET model in the Watershed Explorer. For each of the boundary conditions, there's a collection of methods for modeling it. Not all processes are necessary for all models, and the simplest models may only use precipitation. As methods are added, generally the data requirements increase. Some methods are more complex than others and require more types of data. Each of these processes are more than just data. They're models for representing states of the atmosphere and require data as an input. For example, note that there is no temperature process in the MET model. However, temperature is a data input for snowmelt, evapotranspiration, and so on. MET models are independent of basin models. Since they're general representations of atmospheric boundary conditions and can be set up to work with any basin model, they don't know anything about a basin model unless you tell them. In the component editor for the MET model, there is a Basins tab. Here you'll see all the basin models in your project. If you want a basin model to be usable with this MET model, you must select Include Subbasins Yes in this menu. Otherwise, two things will happen. One, you will not be able to set any sub-basin level settings or parameters if your methods have them, and two, the simulation run will fail and inform you that the MET model is not set up to work with the basin model. This is a common pitfall. It is easy to forget to set your MET model and basin model to work together. You could specify whichever meteorologic methods are appropriate for your modeling goals. Typically, at minimum, a precipitation method will be specified. In the Watershed Explorer, the selected methods will appear beneath the MET model. Clicking on any of those will open the component editor below. The topmost set of icons are for the processes that have been selected in the MET model component editor. Clicking on any of these will let you edit settings for that method. The settings at this level are used across all hydrologic elements. However, some processes are controlled in a much more granular way, such as snowmelt. Gridded methods will eliminate a lot of granularity because they already explicitly handle the atmospheric process in space. Here is a meteorologic model that is set up without any gridded methods. You can see that most of the options for the processes have been pushed down to each subbasin in the model. For some processes, a global editor has been created to facilitate entering and modifying parameters across many subbasins at the same time. Here is an example of a global editor for the temperature index snowmelt method. Because the TI method has parameters that are controllable at the subbasin level, it can be cumbersome to click through each node of the Watershed Explorer tree to set them. The global editor is a faster way to enter these parameters. You can open the global editor for snowmelt by selecting the MET model in the Watershed Explorer, then choosing the Parameters menu and selecting Snowmelt, then Temperature Index, or Gridded Temperature Index. For non-gridded methods, subbasin elements will require a varying amount of gauge information depending on the selected methods. You will need to provide time series data for each of the required variables, which are shown with a red asterisk. For the example on the left side, the Hammond evapotranspiration method and temperature index snowmelt method are selected, both of which require air temperature data. Precipitation methods could take a varying number of precipitation time series, so they are managed slightly differently depending on the precipitation method. Creating the required data and details on the meteorological methods are covered in other tutorials. For gridded methods, grids of meteorologic data should cover the entire modeling domain. These models are explicitly georeferenced, meaning the location of all the hydrologic elements and the meteorologic data are known and referenced to a common datum. Each gridded method will require you to specify a grid data set that you will need to create. The examples on the left are for gridded precipitation, gridded Hammond ET, and gridded temperature index snowmelt. Just like for the non-gridded models, the data requirements are for precipitation and temperature, but this time, instead of specifying it for each subbasin, you choose one grid for the entire basin. This has been your introduction to Meteorologic Models in HEC-HMS. For more information, consult the HMS User's Manual or see some of our other video tutorials on working with HEC-HMS. Thanks and have a great day.